Good morning, Geo. Here we go. We're going to just go straight off of what we did yesterday, okay? Yesterday we talked about proving triangles congruent, and we talked about two of the postulates we used. And we talked about side, 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 where we had to have three sides of one triangle congruent to three sides of another triangle. If that's the case, then we can prove and say that those two triangles are congruent, right? We use that conditional. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. The other one we learned yesterday was side, angle, side. All right, so what we're going to do is we're just going to blow through. We don't have any new tips or tricks for you today. We're just going to talk about those three new ones today. All right, so we're going to have angle, side, angle. So the side is included between the two angles. It's the excluded, or the included, not included angle. So I guess it would be the excluded angle, or side, sorry, and then HL. Okay, so how this is going to work. Angle, side, angle. If two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, triangles are congruent, okay? So what that would look like markup-wise. We have two angles, and where would the included side be? Would it be DE, EF, or DF? And just like yesterday when we talked about the included angle had to be right smack dab in between the two sides. So I liked to highlight the two sides that were congruent, and the angle that was formed by those two sides is the included angle, all right? So when we're doing angle, side, angle, the included side is the one that's connecting the two angles. So if you have the two angles, highlight the line that is on both of them. That's the included side, right? If we can prove that information from one triangle to the other, then we can use angle, side, angle. All right? Angle, angle, side is we have two angles given in the excluded or the non-included side, okay? So what that's going to look like, we could have two angles. This is the included side. So if it's not that one, if they give us two angles and a side, we're good to go. The excluded side would be either BC or AC. Doesn't matter which one of the two, right? So we have the angle, the other angle, and then one of the two sides would have to be congruent to one angle, two angles, and let's say it was this one. Would either have to look like that, or the information we have would be up there. All right, that is angle, angle, side. Doesn't matter which setup again with the side, as long as it's the non-included side. So what you have to look for between the difference between these angle, angle, side and angle, side, angle is, yes, two pairs of angles are congruent and one side. You just have to know, is it the included side or not? All right. And then HL, I asked you guys in this class yesterday, one person came up with the H word, hypotenuse, leg. A lot of you were saying like height and length and stuff like that, which were geometric terms, made some sense, but we are looking for hypotenuse leg because we're dealing with triangles. So what has to happen in order to have the hypotenuse and leg is we have to have this 90-degree angle. So if you're thinking about the other four, we needed to have three bits of information: sides, angles, combinations of both. HL theorem, we have to have three bits of information as well. First things first, we got to have a right triangle. So we're going to have this little checklist, 90-degree angle. All right, does it give us a 90-degree angle? Not every 90-degree triangle is going to be HL, just FYI, okay? Do we have 90-degree angles? The hypotenuse is the long side. and then a leg. It's basically, like if we really wanted to go even further in depth on this, think of the Pythagorean theorem. If you were given the hypotenuse and one of the sides of the triangle, can you find the third side of the triangle? Yep. So if I give you the hypotenuse and a leg of one of the triangles, you could find it, the third one, and it's going to be the same in both cases, right? So the markup for this would be we need to have that 90-degree angle, okay? That box has got to be there. And one other thing, right? This box means 90 degrees, but if there's a little angle mark down there, that's not meaning angle C right now is 90 degrees. That means that's going to be congruent to whatever one of the other triangle, right? That's saying C and F are congruent. That's not a box. So big difference between those two markings right there. I noticed that yesterday having some conversations with kids. So, all right, so we have to have that 90 degrees. The hypotenuse is the long side. And then either that leg or that leg. This is the only time, if you think about SSA or ASS, oops, I just spelled the swear word, that's the only time that works out, where there's two sides and the non-included angle, okay? But it's special because it's a right triangle, right? If we don't have a leg for a 90-degree triangle, we don't have LL, because this would be side, angle, side. So that'd be SAS if they gave you a 90-degree angle and they gave you the two legs. Then you don't have to worry about HL. All right? So in order to be HL, again, it's hypotenuse and the leg. And it has to be 90 degrees. Okay? So let's go through and figure out what they give us here. Are the triangles congruent, yes or no? I don't like this first example, but we'll talk about it. Well, I do like it, I guess. One, are they congruent? Well, what do we have? We have a side, an angle. Do they give us the 90 degrees? And the answer is no, there's no box. So these are not congruent. We would have the hypotenuse and the leg, but if they don't give us the 90-degree angle. So SSA is not a postulate. All right, but if they gave us this 90-degree angle, we would have hypotenuse, leg, we'd be good to go. But they didn't, so we can't. Again, I'm going to go back to that analogy I used yesterday. You can't put a round or a square peg into a round hole. It's just not going to happen. Can't do it. Okay, what do we have here? Right? Ooh, we have a 90 degrees here. Is this angle down here 90 degrees? And the answer is yes. So in our proof, we'd have to say it's 90 degrees because they're vertical angles, right? So we have 90 degrees. Check. Do we have a hypotenuse? Well, that's the long one of the three. Check. And do we have a leg? Yep. Check. So this is yes. HL. Let's do it. All right, what do we got here? Well, we got one angle. We got two angles. So all we need if we have two angles is a side, right? And do we have a side? Oh, yeah. What's that property yesterday? This guy right here, they share a common side. Again, that's the reflexive property. Okay. Is that the included side? And the answer is no, the included side would have to be in the middle of the two angles. So this is yes, because we have two angles on a side, and it's angle, angle, side. Postulate. All right, let's go to this one. What do we have here? One angle, two angle, three angles. Is angle, angle, angle a postulate? And the answer is no. We need to have sides and angles, not all three angles. We talked about it yesterday too. It's similar. So think of this little triangle right here, okay? If I scroll, it's getting bigger. If you're thinking size-wise, I zoom out, it's getting tiny, tiny. But are those angles changing? And the answer is no. So whether we zoom in or, think of blowing up a picture, making it bigger or smaller, it doesn't change the angles. It doesn't change the shape at all. So these two triangles we could say are similar, but not necessarily congruent. All right, and last but not least, what do we have? Angles. And then we have that reflexive property right down the middle. And this is a case where the side is included, so this would be angle, side, angle. So we'd have to put ES first and then angle, side, angle. All right. So what we have down here, below here, no, we got to keep going. State what additional information is required, okay? So we are trying to put angle, side, angle onto this, but right now we only have two sides. So what other information would we need to know in order to use angle, side, angle? Which means we have to have the included angle, the included side. So what would we need to know in order to do that? We would need to know that IH is congruent to CB. Okay? Down here on this one, we want to be able to use angle, angle, side. So what information would we need to know in order to use angle, angle, side? Well, I have two informations. Got an angle and got a side. So what we need to do in order to have angle, angle, side is one more angle. So either I would need angle V congruent to angle T, or you would need angle S is congruent to angle W. All right. HL theorem. 3 checklists for HL is 90 degrees. Got the 90 degrees, that's good. JI and RS, is that the hypotenuse or is that the leg? Good answer, those are the hypotenuse. So that means we have to have a leg, so we would either need JK congruent to RT, or we would need what do I have? JK, so I need KI congruent to TS. All right. So again, going back on this stuff, have that open mind, the growth mindset of some of this stuff might seem difficult. We got to go back to, studying those little tips and tricks we talked about yesterday, because tomorrow we're going to start our proofs. And so what this is, a little cheat sheet for what we just talked about today, right? So this very first one is what it looks like for angle, angle, side with the included side versus the non-included side. So is it angle, angle, side, oops, wrong one, angle, side, angle, or angle, angle, side, okay? Then we got side, 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 and side, angle, side. Right, again, has to be the included. If we're given this angle down here, this is angle side, side. The but theorem is not a theorem. Can't do it. It's got to be smack dab in the middle, okay? Angle, angle, side, angle, and HL theorem. Okay? Things that are, it's not, angle, 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 and then, like I just said, side, side, angle, or angle, side, side. What you might want to do is add to this page or take these concepts and make your own page of notes and put on those properties we talked about yesterday. So we had vertical angles. So if the triangles are connected at a vertex, okay, these two angles here and here are going to be congruent by definition of vertical angles. We had the reflexive property, where the triangles were connected on a side. Whoa, what's going on? And we call that the reflexive property. We talked about angle bisector yesterday. Right, if that's the case, the big angle gets cut in half, then this piece is equal to this piece. That's definition of angle bisector. And we talked about midpoint or segment bisector, which is, we know if it's the midpoint, then we know that it's equal on both sides, okay? And we would use definition midpoint. So we're going to tie all this stuff together tomorrow with our 2-column proof. So we're going to, we started the rough draft process yesterday and today with the information we need. And tomorrow we're going to start putting it together and making a formal 2-column proof. So please reach out if you guys have any questions.